you know, that's a good question. You know, what specific, you know, spectra do plants use at the end of the day? And, you know, that depends on first, one, the plant that you're growing, you know, two, the strategy that you're deploying, and then the environment that you are growing these plants in, whether it's an indoor facility, greenhouse, or whatnot. And so, you know, from this graph, what we can see here is the different photosynthetic responses that we get when we put different light onto plants, right? And so the first term, as we all know here, is photosynthesis. And so that is what plants do, and they use lights as a source of energy for their development. And then the second term that we also see here is PAR. And so this is the light that plants use for photosynthesis, a range of light energy that plants can use for their growth. And so as you can see from this graph here, you have different chlorophyll as well as carotenoids that get excited by the different wavelengths of light. And so as you can see at the bottom, we have the PAR spectrum that's ranging from 400 to 700 nanometers. And a plant's leaf is descripted by the bars or the lines that you see here on the chart. And so as you can see, plants use all of the spectrum within the PAR range. And so when asking that question, it's really about, you know, what's your strategy? Are you going to be doing high light intensity? Are you going to be, you know, producing flowers versus just leafy material? And so, you know, when it comes to cannabis, we would like for growers, especially if you're in an indoor setting, to go for more of a broad spectrum approach.
Cool. Mike, do you want to chime in on the concept of how not all photons are created equal and add on to what Sean was talking about there?
Yeah, absolutely. So yeah, not all photons created equal is a good way of saying, you know, different light spectrums are going to have different effect on the plant. And the plants, I think we all know as growers, the spectrum has a big impact on it. And we've been used to growing only under one spectrum, mostly, you know, either CMH or HPS. And now with LEDs naturally just produce one very narrow wavelength, and that allows us to have nearly infinite variability over the spectrum of the light produced. So where we kind of got what we got before, now we have the entire rainbow of colors to throw at the plant.